Hey students, welcome to my basement. I'm going to try to give you a little bit of background, thinking about the AP test this year, 2020, and with Unit 1 and what they can possibly ask you in a 45-minute free response exam. There's not a whole lot, and so I'm going to try to just break down one of the most important things of atomic structure and what this quantum theory, what the quantum theory is, and kind of how it helps us understand the patterns of what happens with the atom and the different properties of atoms. So the first thing that you kind of have to know is what are electrons and what do we do with electrons and energy, and there's kind of some theories about what electrons are. So some people think that the electron is a particle, but scientists and physicists over time they use this wave theory because electrons are not really in one place. They're kind of in this area, and they're not. It's in a cloud. You should learn the electron cloud method, the model. So the cloud kind of is there, and electrons are there, and they're just kind of somewhere in there. We can calculate some things about them, and so you have to, in order to know some things about electrons and energy, you have to kind of know about waves, and so I'm going to give you just a very brief background about waves and what you can do to calculate them, and then how that leads into the quantum theory. So waves, this is a wave, and if you should know the wavelength, this distance here is called the wavelength, and we use a symbol lambda for that. So that tells me how far apart the wave is, and as the wave waves have energy, and so long waves, like radio waves, they are very low energy. Radio waves are around us all the time. They use them on the radio. They use them for like garage door openers, those types of things. So those waves are around us all the time. Low energy, it doesn't really harm us at all. But and so we say that the frequency of this wave. So frequency is this symbol here. This is nu. So nu, nu. This looks like a V, is in units of cycles per second. So they abbreviate it S to the minus 1. So if you imagine a window here, and this window, the wave's passing through the window, and however many times a wave passes through the windows, that's how many cycles per second. And so if it's a long wave, then it's got so it's a long wavelength. So this is usually in meters or nanometers, but we're just going to go with meters now. If it's a long wavelength, then the frequency is very low. However, if you start shrinking this wave, so as you get higher energy, like microwaves have slightly higher energy, then you get the visible light. So this is like infrared here, and then you have ultraviolet, that's on this side of the wavelength. So ultraviolet, that's more like right past the visible region. That's going to be higher energy. We know that UV rays, if we are outside in the sun too long, they start burning us. They give us skin cancer. So that's higher energy. Start shrinking this wavelength. That now we have more waves passing through this window. So my frequency becomes higher. So as wavelength goes down, the frequency is going to increase. So there's an inverse relationship here. And so there's more and more waves passing through this window. And that's things like X-rays. Now I think it's starting to get really, really, really dangerous. So this is very low wavelength, but high frequency. And then the most harmful are gamma rays. That's from nuclear processes. Lots of gamma rays are coming out. That's really high energy. That can that'll kill you. So, that's the first relationship you have to know is what waves are. And so as I get to the eraser here, so if you look at your equation sheet, on the equation sheet, the front page of your AP equation sheet, if you don't have that, I'll upload that. There's an equation on there, and that's this relationship here. C equals lambda nu. Okay, so C equals lambda nu. Just make sure I've got that right. Yeah, all right. So C equals lambda nu. This is the speed of light. This is your wavelength, and this is your frequency. So the speed of light is a constant, and as the wavelength, as I said, the wavelength gets shorter, the frequency goes up, or as the wavelength gets longer, the frequency goes down. So the speed of light in this case is 2.998 times 10 to the 8th meters per second, and this thing here always stays the same. So one goes up, the other goes down. Okay, so this is your first equation you have to know. Sometimes they might ask you to calculate some things with this, and so what I'm going to do is I'm just going to give you a couple of brief calculations. I'll also give you a worksheet that you can use to practice. So this is a wavelength here. So let's say, for instance, I put the constant up here. Let's say I have this number here, lambda is 3.8 times 10 to the 7th meters, and now I'm going to say what is the is nu, or frequency, in s to the minus 1 cycles per second. So I'm going to plug it into the equation. C equals lambda nu. C is 2.998 times 10 to the 8th meters per second. Lambda, in this case, is 3.80 times 10 to the 7th, negative 7th, times nu. Okay? If I want to solve for this now, I have to divide both sides out by this number. So I'm going to take 3.80 times 10 to the minus 7. This cancels out to get that. And then in your calculator, you can go to your function that has the fraction thing on there. That's all about 2.998 on top, and then the 3.80 on the bottom. Okay, I'm using the E button here. If you can see that, I don't know if you can see it. And then my nu here ends up being 7.89 times 10 to the 14th, and then that's cycles per second, so s to the minus 1. Okay, so that's one starting calculation you should know for doing this unit. The other thing too is well, these waves have energy. How can you calculate the energy for that? And so to calculate energy, there's another equation. There's only two equations on the equation sheet in this section, and that is this one right here. Let me get you. So energy equals H times nu. So this is the other equation. Energy, this is called Planck's constant. Planck's constant, named after Max Planck, and Planck's constant is right here. Okay, so this is also on your equation sheet. Really, you just plug in the numbers. So the units on here are joules, joule seconds. So it's not joules plural; it's joule seconds. And you're going to take the H, plug it in here, and let's say I want to get the energy of this wavelength. So I'm going to take the nu, my frequency that I calculated here earlier. So I'm going to take E equals 6.626 times 10 to the negative 34. And then I'll put this in here. 7.89 times 10 to the 14th. Okay, so take that, multiply it out. And you end up getting 5.23 times 10 to the minus 19th. And this is in joules. Okay, so those are some starting calculations you should know how to do for this section here. I'm going to stop it, and then we'll make another video about what that tells us for the quantum model.